Problem 69 is another really tough problem right here. Got y is equal to, holy cow, and there's 3 square roots that are embedded here. So I think the very first thing we ought to do before anything else is rewrite this expression in a different way here, because those square roots don't really help us all that much. Okay, what's going on, guys? I'm going to rewrite this now as our radicand here, all being taken to the 1/2 power. So I've got something now to the 1/2, and what is that something? Well, it's a 1 plus, well, shoot, then it's another square root. So I'm going to rewrite that square root there, okay, as another something to the 1/2 power. Gotcha. And what is that? It's going to be 1 plus the square root of x. Well, rather than writing that as square root of x, I'll make that an x to the 1/2 power as well. So if the original expression had 3 square roots in it, hopefully it makes sense then that with what we've rewritten here on the right, we've got 3 1/2 powers. Okay, let's dive in, see how we can do with this one. So the derivative of y taken with respect to x will equal, here we go, starting with this 1/2 right here. That derivative will put a 1/2 out in front, and then everything on the base will stay the same. 1 plus, parenthesis, 1 plus x to the 1/2 power. Close that parenthesis to another 1/2 power, close that parenthesis. And then that entire base right here now has a power that drops by 1, so that'll be to the negative 1/2 power. Whew! And that's the outer part. So that's the derivative of that first 1/2. But then we now have to multiply by the derivative of that base, which is everything here in red. So times, here we go. Derivative of that 1 is 0, so forget about that. And the derivative of this, 1 plus x to the 1/2 to the 1/2. All right, this 1/2 comes out in front, and here we go. It's 1/2 times the same base of 1 plus x to the 1/2. Drop the exponent by 1, so that's now a negative 1/2, but we're not done yet, times the derivative within. So we're going to multiply by this derivative here at the end of all that. Well, the derivative of that 1 is 0, and the derivative of x to the 1/2 is a 1/2 x to the negative 1/2. Okay, and that, guys, should be all the calculus here. Now, again, it becomes this very, very messy simplification problem. Let's see what we can come up with here. All right, I know I'm going to have a fraction here. I see a 1/2 times a 1/2 times another 1/2. That's going to give us a 1/8, which will put an 8 down there on the bottom. Boy, and as I'm looking at it, I don't know that anything here is going to stay in the numerator, so I think I need that 1 up there. And I tell you what, I actually want to attack this one backwards because I think it'll be a little easier. X to the negative 1/2 is going to give us a square root of x down in the denominator. Then this quantity right here, since it's also taken to a negative 1/2 power, gives us another square root in the denominator. And it's the square root of 1 plus x to the 1/2, which is the square root of x. So I took care of that. And now I got this whole mess to worry about, which again is something to the negative 1/2 power. So it's another square root in the denominator. And what's it the square root of? There's a 1 plus, and remember, all of this to the 1/2 power is another square root of 1 plus, and then x to the 1/2 is a square root of x yet again. And that took care of all of that. And the 1/2 and the 1/2 and the 1/2 is how I got the 1/8. So I think at this point right here, guys, that is really, really ugly, but we are done. And I think that's our derivative now. dy dx is equal to that. It would be possible using the property that says the square root of a times the square root of b is equal to the square root of ab. You could start combining all of these radicals here, but boy, it would be so messy, and with the radicals times other, I don't think that's worth it at all. So I'm pretty comfortable with that answer here for problem number 69, the way that we have it written right there. So box that up and ignore that, and I think we're good to go.